In addition to the common forces such as gravity and friction and drag, there are some less common forces that don't show up as often in mechanics but are useful to understand just generally how they work. And I'm going to talk about just a few of them here. We have lift, thrust, the buoyant force, and electric and magnetic forces. Now, electric and magnetic forces you'll learn about when you study electricity and magnetism, so we won't go into those, but the electric forces are between electrically charged objects. Magnetic forces are between moving electrically charged objects and magnets and magnetic fields. But these three forces, let's just discuss what they are. So first of all, lift is a force that acts on objects that are moving through a fluid. Air is a fluid, water is a fluid, and lift is going to apply a force perpendicular to the motion. So in this case, our plane is moving in this direction, and there's a lift force on the wings that lifts it up. Lift is complicated. It's caused by pressure differences on the different parts of the shape of the wing, for example, but it ends up with a net upward force. So can we draw a free body diagram for a plane flying horizontally and speeding up? So if this is my plane, we know that gravity is going to act. How's it going to move forward? Well, there's going to be some applied force from the engines. We actually call that force thrust, which we'll talk about in a minute. Thrust. Drag is going to be slowing it down, and since it's speeding up, thrust has to be bigger than drag. And why doesn't the plane fall to the ground? How can it fly? It needs to cancel out gravity, so there's going to be a lift force. The velocity is to the left. The acceleration is to the left. Thrust is the force from a rocket or a jet engine or a propeller. Thrust involves pushing some fluid in one direction. And as that fluid moves backwards, it pushes the object forward. It pushes the engine forward. The rocket pushes out a bunch of hot gas, and the rocket feels a forward thrust force in the engine. Jet engines also involve thrust. You can think of helicopters as thrust as well. The buoyant force is a force for any object that's also inside of a fluid. If you've ever seen a beach ball in the water, it floats. That's caused by the buoyant force. A helium balloon that floats up to the sky, that's caused by the buoyant force. And whenever any object is inside a fluid, there's going to be a buoyant force acting on it. That buoyant force always pushes up, opposite gravity. The size of the buoyant force is equal to the weight of the fluid that you've displaced. For example, if you place a ball in the water, you have to move a certain amount of water out of the way to get that ball there. The upward force on the ball is equal to the weight of that volume of water that you displaced. Meaning there's a buoyant force on you right now because you're in a fluid, air. It's just that the weight of air is very small, so the buoyant force is very small on you. But you can feel that buoyancy when you go into water. So denser fluids, if you displace a denser fluid, you're going to have a greater buoyant force on you. What's the free body diagram for an airboat traveling at a constant speed through water? Well, this is an airboat. An airboat involves a propeller. So what are the forces acting on my airboat? Well, it's floating at a constant speed. We know gravity is always acting, so I'm going to do a downward force of gravity. What's canceling out gravity? It's not the normal force. It is buoyancy, so I'll call it FB. There's a forward force, and that forward force is, well, it's thrust. It comes from propelling the air backwards. So I'll just call it thrust. And how are we going at a constant speed? It's because there's a lot of drag. Drag force from both the water and the air give us a constant speed motion. Oh, and that's all. Bye.